Hello everyone, this is Divyanshi Pathak. I'm student at International Institute of Professional Studies, DLV University, Indore. Today in this video, we will be solving end semester question paper of numerical analysis and design. So without further ado, let's start. So the question number one says that find the point of the polynomial x squared minus x minus 1 through fixed point iteration method. Also make a table for the various possible equation and show their nature, whether they are convergent or divergent in nature. So let function f of x be x squared minus x minus 1 as given in the question. Now we will put 1 in the given function f of x. If we put 1 in this equation x square minus x minus 1, the result will be negative. And if we put 2 in the given function, the result will be positive. So our root will lie between the point 1 and point 2. So we can take x naught equals to 1.5, which is the median value of 1 and 2 for further calculation. Now, this is the table of g of x. G of x is nothing but a polynomial derived from f of x only. There are four possible g of x for the given function x square minus x minus 1. The first g of x is under root x plus 1. Second is 1 upon x minus 1. Third is 1 upon x plus 1. And the last one is x square minus 1. We will also find the respective derivatives of all g of x's. And now for the further calculation, if we have to select g of x, then it must satisfy two conditions. The first is the absolute value of g of x should be less than 1. And the second is if multiple value of g of x are less than 1, then choose the least one. Now this is table for convergence. For first g of x under root x plus 1, if we substitute 1 in it in g of x, its value will be less than 1. And if we substitute 2 in it, its value is again less than 1. So for both the cases, the value is less than 1. Hence, this is the case for convergence. And for the next g of x, 1 upon x minus 1, if we substitute 1, its value will be greater than 1. And if we substitute 2, it will be greater than equal to 1. Now, this is the case of divergence in which the value is greater than or equal to 1. For the third case as well, it is a case of divergent because one value is greater than equal to 1 and another is less than 1. So the case of convergence only occur when when the value of function for both the point is less than 1. We have chosen g of x as under root x plus 1 for the fixed point iteration method. As we have considered earlier, x naught is equals to 1.5, which is median of 1 and 2. We will calculate the value of x of 1 by substituting x naught in the given g of x. So the value of x1 is 1.5811. Similarly, we will calculate the value of x's till the 7th iteration. Here we see that the value of x6 and x7 are approximately same. So our root for the function for the polynomial x squared minus x minus 1 is 1.618001. Now moving towards the next question. The second question says that find the solution of the system of equation using iterative method. Now, so these are the three equations given: 20a plus b minus 2c equals to 17, 3a plus 20b minus c equals to minus 18, 2a minus 3b plus 20c equals to 17. So we have to find the value of a, b, c respectively. Firstly, we will take one variable on the one side and we will move rest of the variables on the other side. So by doing this, we will get these three equations, which are a equals to 17 minus b plus 2c upon 20, b equals to minus 18 minus 3a plus c upon 20, c equals to 17 minus 2a plus 3b upon 20. Now, for the first iteration, we will consider a naught, b naught, c naught all as 0. So we will get the value of a1 as 0.85, b1 is equals to minus 0.9 and c1 is equals to 0.85. Now to calculate the value of a2, b2 and c2, we will substitute a1, b1 and c1 in the previous equations of a, b and c. So similarly, we will calculate the value of A3, B3 and C3 and also A4, B4 and C4. Now here we see that the values are repeating in the third and fourth iteration. So we will follow this step till we get the repeated approximate value. So the values of variables for this question is A equals to 0.96, B equals to minus 1.014, C equals to 6014. Now, next question. List out 4 disadvantages of Gauss elimination and 3 advantages of iterative methods over the elimination method. So the iterative methods are superior to the elimination method because of the following reason. First, the computational effort is approximately 2n square arithmetic operation per iteration, and if the convergence is achieved in less than n iteration, it is significantly superior compared to the elimination method. The another important advantage of the iterative method is small rounding error. So in iterative method, there are very less chance of getting rounding of error. So for the ill-conditioned system, it is good to use iterative methods over the elimination method. The third point says that in Gauss-Seidel method, we set x of I equals to the newly calculated value of the iterate stored in time. Basically, it reduces the computational effort as well. The disadvantage of Gauss elimination are as follows. The computational effort is approximately 2n cube upon 3. Arithmetic operation in each elimination step. The amount of bookkeeping necessary is considerable. The rounding error may be quite large, particularly for ill-conditioned equation. That's why we prefer iterative over elimination. Also, any special structure in the matrix of coefficient is difficult to preserve during elimination. So these were some advantages and disadvantages of iterative over elimination method. You can read it. Now next question. Write the algorithm for Lagrange inverse interpolation. In first step, we will read the number of inputs n. In second step, we will read the values of x. In third step, there is a for loop which is initialized from I equals to 0 till I equals to n minus 1 to read all the values of x and y. Now in fourth step, we will set some variable to 0. Now in fifth variable, again there is a loop for variable I initialized from 0 till n minus 1, within which there is a product variable which is initialized to 1. इसके बाद इसके अंदर फिर से एक nested loop है for variable j which is initialized from 0 till n minus 1, within which there is a if condition for I not equals to j. If this condition is true, and then the value of product will be updated by product into y minus y of I upon y of I minus y of j. Now, after the inner loop will be ended, the sum is updated to sum equals to sum plus x of I into product. And at the last step, the value of sum will be printed. So this was algorithm for Lagrange inverse interpolation. Next question, evaluate the integrate under the lower limit 0 and upper limit 1 for the function 1 upon 1 plus x square using the 3-point quadrature formula for the given abscissas and weights. So the given abscissas are T1, T2 and T3, and the given weights are W1, W2 and W3 respectively. Here we will consider two variables where A is initialized to 0 and B is equals to 1. Now, the formula is x is equals to b minus a upon 2 multiplied by t plus b plus a upon 2. Now, putting the values of a and b in the above formula, we will get x as 1 plus t upon 2 and d of x is dt by 2. Now, substituting the values of x and d of x in the function, we will get the function f of t is as 0.78527, which is the answer for the question. Now, the next question, write an algorithm for the Wedel rule for the 6 points. In the first step, we will read the starting point, and second step, we will read the end point. And with the help of starting and ending point, we will calculate the value of h in the third step, which is h is equals to n minus start upon 6. Here 6 is taken because in the question it is mentioned that we have to write an algorithm for the 6 point. Now in the fourth step, there is a for loop for the variable I initialized from 0 till 6 to read all the values of y. In fifth step, we will evaluate the value of x using the function using the formula 0.3h within the bracket y0 plus 5y1 plus y2 6y3 plus y4 plus 5 plus 5y5 plus y6. And at last, we will print the value of s. Now, the next question, write the algorithm for the Runge-Kutta fourth order expression. And the first step, firstly, we will take a function f which take two parameter x and y and return the given expression. In the second step, we will read starting, ending, and splits. In the third step, we will evaluate the h using the previous values of starting, ending, and split. Here, h is equals to ending minus starting upon splits. Now, in third, there is a while loop for the condition starting less than equals to ending. To calculate K1, the formula is h into function for the parameter x and y. Here, the function f is evoked and it will return the expression which will be multiplied to the value of h and will give the value of k1. Similarly, k1, k2, k3, and k4 are evaluated. And the x is equals to x plus h, starting is equals to starting plus h. Now, y is calculated with the help of formula k1 plus 2, k2 plus 2, k3 plus k4 upon 6 plus y naught. And at last, we will print the values x and y. Now the last question, apply predictor corrector method to solve dy by dx is equals to minus xy, where y of 0 is equals to 1 and the step of 0.1 up to y 0.2. So here's our two formula. First formula of y is for predicted value and the second is for the corrected value. And by Hume's method, the k1 is f within the bracket xi and yi, k2 within the function within the bracket there are two parameters xi plus h by 2 comma yi plus k1 h by 2. Now to evaluate the value of k, we will take the median value of k1 and k2 which is k1 plus k2 upon 2. Now ki plus 1 is equals to y ith plus kh. Hence, the value of y is at 0.1 is 0.9975 and y at 0.2 is 0.98005. It is calculated by predicted formula, so it is the predicted value. And the corrected value of y at 0.2 is 0.982712. So we can apply corrected formula again to get the more accurate value by putting the corrected value as a predicted value in the corrected formula. So that's all for today's video. Thank you so much for watching.